Hello, I've had a question in Unit 4, Lesson 6, and this is the second part of the homework, and I'm looking at question 39. So this one's a little bit more challenging just because of the algebra. So basically what's happening is we have a shoreline running right here. Here's my island. We know the island is 4 kilometers offshore. We know that the desired location, the pub, is 8 kilometers downstream, or down the shoreline. What's going to happen is the person's going to take off rowing, and we want to find the optimal point for them to land. So we are trying, in our optimization equation, we are attempting to optimize time. Now, off to the side here, we know that distance equals velocity divided by time from physics. So time is distance divided by our velocity. So if we're going to optimize time, our time is going to equal T1 plus T2. So T1 is going to be the time it took to row. T2 is the walking time. So that means it's going to be distance 1 divided by velocity 1 plus distance 2 divided by velocity 2. So that means we've got to find D1 and D2. So I'm going to have D1 is this distance and D2 is this distance. I'm going to keep it simple. I'm going to say D2 is just going to be a value of x right here, which means this will be 8 minus x. So that's where my constraint equation will come from. Can't spell constraint or the short form for it, but that's beside the point. So we know that D1 squared is equal to 4 squared plus 8 minus x squared, or D1 would equal 16 plus 8 minus the 8x squared to the 1/2. So there is my constraint equation, which is going to go up into there, to my optimization equation. So now I can do the substitution for time. So velocity, so I'm just going to write that as 1/3 bracket 16 plus 8 minus x squared to the 1/2 plus my second distance is just a value of x over, let's just write it in fraction form. Velocity is going to be 5 kilometers an hour, so 1/5 x. Now I can take the derivative of the overall time with respect to the landing point x. So I'm going to do this as carefully as I can. So 1/3 is out front, taking the derivative. 1/2 will come down, leaving me with 16 plus 8 minus x squared to the negative 1/2. Just move that a little bit. Then taking the derivative inside, derivative of 16 is 0. 2, 8 minus x to the exponent 1. And then the derivative of in there is negative 1. Plus, and just becomes 1/5. So this is where now we let dt by dx equal 0. And I'm going to simplify a little bit. So I see that the 2 that popped out there cancels with that 1/2. Excuse me. And I end up with negative of 8 minus x on top divided by 3 and the square root of 16 plus 8 minus x squared plus 1/5. Alright, so moving that over, I'm going to have 8 minus x over 3 square root of 16 plus 8 minus x all squared equals 1/5. What I'm going to do now is I'm going to cross multiply to get rid of the fraction. So that means I would have 5 times 8 minus x equals 3 square root of 16 plus 8 minus x squared. Gotta get rid of that square root, so we're going to square both sides. So we end up with 25, 8 minus x squared equals 9 times the 16 plus 8 minus x squared. We need to FOIL this term here. So foiling it and expanding it with the 25, I end up with 1600 minus 400x plus 25x squared. On the other side, same thing, has to be FOILed over here as well. Then I do the expansion with that 9, and I end up with 144 plus 576 minus 144x plus 9x squared. So that's after doing my expansion and everything else. I'm going to move everything to the same side, so everything to the left side. So I'm going to simplify to 16x squared minus 256x plus 880. That's equal to 0. Now, fortunate for us, everything's divisible by 16, which brings our equation down to this, which is really nice, which means I'm not going to have to use quadratic formula because this factors to become x minus 5 and x minus 11 equal to 0. So therefore, x equals 5 and 11. Now, 11 is inadmissible. And the reason for that, if we look where we started up top here, if we were to land 11 kilometers down, that means we'd be exceeding the 8 kilometers that we originally had. So that means that we are going to actually land 5 kilometers from the pub, or 3 kilometers from across the island, which I think that's the answer that is given in the solutions, across the island. Alright, so that would mean, if I bring up my picture again, just scroll up here, so we're going to land, this distance here is going to be 5, this distance here is going to be 3, and that optimizes the time it took to move, or to get from the island to the desired location. So again, it's the algebra that could probably cause the challenges. If you have any questions, let me know and I will try to clarify.